ever just wonder if you could finish counting? Like, could you count forever and ever and ever, never stop counting? Could you get to a number so big that it's the end of numbers? Well, believe it or not, mathematicians have actually studied this question, and the answer might surprise you. Spoiler alert, it's yes and no. And by the end of this video, you'll know exactly what I mean. Okay, let's do this. How do we even start to figure out if we can count forever? Well, the first thing to realize is that counting is really just a method for keeping track of things. When you count, you're really just assigning a unique label to each thing you're counting. The first thing gets the label 1, the next thing gets the label 2, and so on. So with counting, we have a couple of rules. Rule no. 1. Each object gets exactly one label, and rule no 2. Once an object has been assigned a label, that label never changes. Now, these rules are actually pretty important. They're the foundation of what we call one-to-one correspondence. And if you've taken a course in discrete math, you may have actually seen it represented by the symbol g to the n. That's because the function g here represents the assignment of labels. And n is the set of natural numbers, which is basically counting. So g to the n is really just a fancy way of saying counting. Now, for our purposes, we're just going to call the set of natural numbers n, because honestly, it's kind of a pain to write all of those letters. But we're still going to need to make a couple of observations about the structure of n first off. N is infinite. There are just infinitely many natural numbers. Also, the natural numbers are well ordered, meaning that every subset of n has a least element. For example, if we take the subset 2, 4, 6, then the least element is 2. Or if we take the subset x, x is even and x less than 10, then the least element is 2. So that is 2. But what is the least element of n itself? Well, that's 1, right? 1 is the least element of n. Now, the reason that these facts about n are relevant is that they are actually true of any set that is the result of a one-to-one correspondence with the natural numbers. Here's an example. Consider the set of even natural numbers, which we can define as 2, 4, 6. It's clear that this set is infinite because there are just infinitely many even natural numbers. And it's also clear that this set is well ordered because if we take any subset, say 4, 6, then the least element is 4. So even though the set of even natural numbers isn't the same as the set of all natural numbers, it has the same structure, it's infinite and well ordered. In fact, every infinite and well ordered set has the same structure as n. They're either both infinite and well ordered or neither. This might seem kind of technical, but the upshot is that if we can count the objects in one collection, then we can count any other collection that has the same structure. So back to the original question, can we count forever? The answer is yes, we can count forever. We can always find another object to count. We just make up an object and assign it a new label. But that raises an interesting question. If we can always find another object to count, does that mean that we can never finish counting? Well, the answer is yes. We can never finish counting. Because if we did finish counting, then the set that we're counting would have to be finite, meaning that there would have to be a largest element. But we know that the set of natural numbers is infinite. Therefore, we can never finish counting. Okay, thanks. Bye.